Hello, my name is Christina Z. Riggs. I am a senior chemistry major at Georgia Southern University. In this slideshow presentation, I will be discussing X-ray fluorescence spectroscopy. X-ray fluorescence spectroscopy is a non-destructive analysis technique that is used to analyze major and trace elements in geological material. This technique provides information about the elemental composition of metals and minerals in a sample. X-ray fluorescence spectroscopy is used in analyzing soil surveys, mining, cement production, environmental studies, glass production, and field analysis, just to name a few. Now that you know what X-ray fluorescence spectroscopy is used for, let's talk about the chemical level process of how it works. A strong X-ray beam, also known as an incident beam, illuminates the sample as well as scatters and absorbs some energy. The atoms ionize and eject electrons from a lower energy level to absorb the X-ray energy. The electrons from a higher energy orbital replace the electrons that were emitted, causing the release of energy. The energy of the electrons released emit a set of characteristic X-rays which help determine the type of atom present in the sample. Detectors are then used to measure the qualitative and quantitative data, making the determination of the elemental composition of the sample much more accurate and precise. This is an instrumental diagram of an X-ray fluorescence spectrometer. The X-ray source is an empty chamber with a heated cathode, usually made of tungsten wire. When the electrons are heated by the cathode, they are released and accelerate towards the anode. Once the incident beam comes in contact with the anode, the beam excites the sample and energy is released. This information is sent to the X-ray detector, which then sends out the results of characteristic X-rays to the computer for analysis. X-ray fluorescence spectroscopy signals are measured according to the quantitative and qualitative data that they provide. The quantitative data is provided by the intensity of the radiation at different wavelengths. The qualitative data is provided by the wavelengths of the energy released. There are two X-ray fluorescence spectroscopy methods that can be used to gather information. The first method is wavelength dispersive X-ray fluorescence spectroscopy. This method is older and can only measure the wavelength of an element, one element at a time. The second method is energy dispersive X-ray fluorescence spectroscopy. This method can collect information of multiple elements in a sample at once and can also provide better energy resolution. This technique is discussed in a peer-reviewed research article, Rapid Determination of Heavy Metals in Soil Using an X-ray Fluorescence Portable Instrument. The objective of this research was to obtain 10 samples of soil from an old industrial area in Romania. With the use of a portable X-ray fluorescence spectrometer, to test for metals in the soil associated with the production of food, recycling water, and other raw materials that society consumes. The scientists whom conducted this experiment found that the elemental composition of the metals and minerals in the soil samples were above the normal limit. The advantages of a portable X-ray fluorescence spectrometer is that it is a fairly inexpensive instrument. It costs roughly $75,000 to $125,000 to obtain. Portable X-ray fluorescence spectrometers are faster than laboratory X-ray fluorescence spectrometer instruments. Portable X-ray fluorescence spectrometers are great for bulk analyses of major and trace elements. The results of a portable X-ray fluorescence spectrometer tend to be in higher amount than that of laboratory analysis using X-ray fluorescence spectrometers. The disadvantages are that there is no distinction of the variation of isotopes of an element. There is no distinction of ions of the same element in different valence states. Portable X-ray fluorescence spectrometer instruments can only give accurate information if the sample is greater than 1 gram. X-ray fluorescence spectroscopy is helpful in many aspects of chemistry, such as forensics, soil surveys, cement production, and other environmental studies. X-ray fluorescence spectroscopy works by the excitation of a sample via incident beam. Once the sample is excited, the instrument produces a spectrum of characteristic wavelengths to help determine what atoms are present in a sample. In the research experiment, the goal was to test for metals in 10 soil samples using a portable X-ray fluorescence spectrometer and compare the results to the non-portable X-ray fluorescence spectrometer used in a laboratory. The portable X-ray fluorescence spectrometer was found to be a quicker, more efficient method. This concludes my presentation.